everyone, and thank you for attending today's webinar, Open RAN and the Energy Efficiency Imperative, sponsored by Wind River. Before we begin, I will cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, please type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green resources widget. Near the end of today's presentation, please take 1 minute to complete the survey that's open on your screen. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Ruth Brown, Principal Analyst, Mobile Networks, Heavy Reading. Ruth?
Thank you very much, Barbara. So hi, everyone, and welcome to today's webinar. So Open RAN and the Energy Efficiency Imperative. So this is going to be a review of the current state of energy efficiency with actual steps CSPs can make to optimize their network. Today I'm going to be moderating the discussion, which I'm absolutely delighted to do. And I'm going to also be joined by 4 fantastic speakers. So we have Andy Duncan, who is Open RAN, RF and Digital Platform Development Manager at Vodafone. We have Prakash Desai, and Senior Director, Product Management, Intelligent Cloud at Wind River. We have Billy O'Connor, Lead Solution Manager at Samsung Networks Europe, and Sindhu Cherasagar, who's the Senior Director of RAN Software and AI Solutions at Intel. So most of this webinar today is going to be a panel discussion, but I'll share a little background before we move on to this aspect. I'm sure throughout the webinar there's going to be many questions coming up, so please, as Barbara mentioned, add them into the Q&A box in the webinar widget, and we'll answer as many as possible when we get onto that section. So let's start off with looking at energy efficiency. So measuring a business's impact on society and the environment is now a really top priority for operators. And this is also along with ensuring they have full transparency and accountability. And this is becoming really important to both investors and also customers as well. So part of ESG tracking is documenting the energy usage. So the chart that I'm showing on this slide here shows a typical operator example, and I've actually taken the data from Vodafone Group PLC's 2024 ESG addendum data, and this is for their sort of global data usage. So the graph is basically to illustrate the large amount of energy that both fixed and also RAN networks use within a mobile operator's business. So if we just look at mobile base stations for an example, we can see 66% of Vodafone's global total energy usage is just base stations alone. And this is a similar proportion across other operators. Sometimes it's a little bit higher. As we move into 5G, we're seeing newer technologies such as massive MIMO also increasing power consumption, so roughly by about 3 to 4 times compared to with LTE. So understandably, this is becoming more of a need, more pressing demand for operators. So they're really striving to become more energy efficient and also control their power consumption. Today, we're going to focus our energy efficiency discussion, and we're going to center it around Open RAN and the Open RAN ecosystem. So this ecosystem, as you can see on the diagram on the left-hand side, integrates, deploys, and operates radio access networks using components, subsystems, and also software from multiple suppliers and over the multiple open interfaces, which you can see in the diagram. So ORAN already has energy efficiency focuses, and it's based on 4 pillars. And these include areas such as energy efficient hardware, energy efficiency KPIs to document the energy usage, and also specific features to improve energy efficiency. So these are things such as network design, cell shutdown, etc. There's also an aspect around intelligence and orchestration to automate energy efficiency. And in today's panel, we're going to touch on many of these pillars and discuss design and architecture, also look at power efficient operation, intelligence, and also guiding principles that are going to help people get towards carbon neutrality. So without delay, I'd like to ask Andy, Billy, Prakash, and Sindhu to come off mute and join me for today's discussion. So welcome, everybody. Thanks so much for joining me today on the panel.
Thank you, Ruth.
Everyone just say hi. Yeah. I'll just check your microphones. Brilliant. Good to have you all.
Thanks.
Great. So I guess without further ado, we've got a number of topics that we're going to talk through today. The first topic that we're going to sort of tackle and think about is really around energy efficient features and designs. And I suppose specifically how operators are achieving greener networks while also keeping performance, quality, power efficiency. So we're hearing about, the 5G use cases. A lot of them are very much performance dependent. So I wonder if we could come to you first, Sindhu, with your sort of thoughts around this.
Yeah. First of all, it's my pleasure to share this space with you all. It's wonderful to have this session. So open, fully virtualized RAN architecture based on COTS hardware and general purpose CPUs give you the maximum flexibility to minimize power consumption. I'll give you some examples, right? First of all, you can deploy less servers and less compute capacities, fewer servers, fewer cores. Why? Because you can run infrequent services like OAMs, for instance, at night on those same cores that you were running for traffic processing during the day. You can support multiple 3GPP generations on the same processor. Samsung, for instance, has software support for 2G, 4G, and 5G on the same server for a BDU. And this allows for ripping out of old power-hungry 2G equipment. So you get a lot of power savings there. And then you can continuously improve software performance to achieve better performance per watt. You can add 3GPP features. We keep coming up with new releases on that end. And then you can also have other innovations with software, and instead of having to replace hardware, and that what we call evolve without overhaul. Finally, as we move towards more centralized architectures, you can allocate general purpose processors across more workloads and then be able to improve your sustainability profile even more. So the open virtualized RAN architecture is an excellent green architecture. It provides opportunities today to save energy, and then in the future, progressively improve upon those power savings with software upgrades and future processor generations as well.
Oh, thank you, Sindhu. That's probably a really good point actually to talk to Andy. So Vodafone have been sort of very vocal about support for Open RAN, and you're also starting to deploy at volume now. I wonder if you can sort of give us some insights about how you're kind of achieving this sort of greener network, and sort of add on from some of Sindhu's points that she's just made.
Sure, Ruth. Yes. It's this is probably now the key metric for the obvious reasons, and this break it down into some specific areas. As an operator today, we go far deeper into the network design, the design of the radios, the compute platform, and the software that supports it. So we have engagements now, deep into the world of silicon and software, something that perhaps 5 or 10 years ago certainly we weren't doing, and that's enabling us to develop a much better approach to some of these key challenges, as you say, balancing performance, energy efficiency, and of course TCO, which is critical for every operator, and of course not forgetting the quality of service that we have to deliver to our customers, and those services are always evolving, developing, and we have to keep up the rate of change to meet those demands. But what's really important, I think, and presented the opportunity that we have here with the O-RAN platforms and architectures is that we really need now, today, to look at this in a far more holistic manner. Previously, we'd have chosen best-in-class radios, we'd have put them with best-in-class baseband, and that would probably have been considered, a very good platform. But what we're looking at now is that we need to also, with that holistic approach, end-to-end intelligence running through the platform, enable the platforms to better track the applications and the usage that we see happening. And that's something that we've worked hard to push into the O-RAN architectures over recent years, is to give us these hooks, these interfaces, and the ability with aspects such as the SMO and the two RICs to really build far more intelligent platforms. And that's how we're going to get the best out of our platforms going forwards, and ensure that we can deliver, hopefully, year-on-year enhancements in reducing energy consumption. We still continue to work really hard with all of the critical components. So as Cindy was identifying, in the compute platform, we've got to drive down power consumption of the CPU. And one way to do that is not just wait for the next generation of silicon. It is about how that silicon actually applies for resources, how many cores we use, how we manage the cores. So we're getting down to a very low level of detail, but actually can bring significant enhancements in performance. It's true also for the radios. We can look at the classic areas such as the power amplifier, which consumes 50 or 60% of all the power from the radio head. But if we can implement new technology there, we can improve the Doherty. We still see a roadmap of evolution over the next 2 to 3 years. Will bring further enhancements, both in terms of PA technology, but also the silicon technology. So the options are there. We've got numbers of different buttons that we can press, but the important thing is that we start to look at this platform as exactly that, one platform with intelligence that will enable us to really bring the optimum implementation to match the different applications and deployment models that we have to as an operator.
Thank you, Andy. You've sort of touched on everything there. Prakash, I wonder if we can sort of add on to that, specifically about the workloads as well. Andy's mentioned there's multiple requirements. How are you working to kind of support the ecosystem and to build in power efficiency?
Thank you. First of all, thank you for inviting me to this forum. It's a pleasure to be part of this panel. Both Sindhu and Andy provided some great insight, and I would just like to add some color to what they have already said. I believe there are two main technological advancements that have happened which help us improve on energy consumption in the new networks, especially 5G. Right? So the 3GPP specifications paved the way for virtualization of 5G networks. And then the service-based architecture helped us disaggregate hardware and software, specifically on the RAN side, right? And in addition, as Andy was mentioning, the Open RAN architecture has opened up some critical interfaces where we can actually go and integrate intelligent network functions and introduce closed-loop automation to achieve optimization of energy consumption. So now, if you were to take that and come to some actionable items, I think, like Sindhu was alluding to, we can start by deploying energy-efficient hardware for quad servers, routers, switches. That's the basic. On the software side as well, case in point, the Wind River Cloud Platform, we just run on a single core, like Andy was mentioning. It's also important to see how can we optimize the software side as well, right? So the Wind River Cloud Platform today runs on a single core of Intel Sapphire Rapids. And what that enables is, it enables the carriers to deploy more and more workloads on the cores that are freed up. So thereby reducing the total hardware footprint that is deployed at a cell site, and thus reducing the total power consumption. Another aspect is the ability to cloudify the network function, whether it is a VM or containerized. We can host multiple network functions on a single server or fewer servers if it's a large cell site. And the single most benefit of hosting network function on a server is basically to the ability to scale as the network demand grows, thus optimizing the power consumption. Finally, there are areas such as dynamic power control, employing renewable energy at cell sites, using advanced cooling systems, all of which can add to energy savings. And coming to the point about network performance, both Verizon and Vodafone, who are our customers, have publicly stated that for vRAN and Open RAN, the KPIs are as good or better than traditional RAN.
Yeah, thank you. That's really interesting to know, especially about the KPIs, because obviously that's a big aspect, isn't it, to actually understand what your current performance is and use it. Billy, I wonder if we could come to you next, sort of with your thoughts, obviously around how you're working with the others as well to achieve these power efficient operations.
Yeah, sure, Ruth. And again, thanks very much for inviting us and facilitating this today. So I guess when we talk about green network architectures and ensuring and guaranteeing performance and quality of power efficiency, etc., if we think back, the industry itself has now embraced virtualization and openness for a number of years. And I guess what we have in the panel today here, Samsung, along with the other partners here today, are really at the forefront of this innovative change. So I think you've heard it already through the various kind of summaries that we've had. But when we talk about achieving greener networks and guaranteeing performance, really we believe in the future of software and the power of driving networks through software to deliver both agility and greener networks. So by embracing a software-centric network architecture like vRAN and working with the partners here, operators can optimize both the deployment and management of RAN services. And of course, this increases efficiency, it reduces operational costs, so obvious benefits. An example of this would be our vRAN 3.0 solution, where operators have access to features like energy saving feature orchestrator. So this is a product that manages multiple energy savings features. It's focused on optimizing energy efficiency without service interruption, which again is paramount from a performance perspective. So this software-centric approach, I guess, if we take a step back, it provides greater control over resource allocation, and it also facilitates tailored service offerings. So not only does it offer you this kind of granular resource allocation aspect, but it also drives business growth opportunities. And of course, this is key to customer satisfaction. So what I would say is, in addition to all of that, is operators really not only have the ability to improve the energy efficiency or the energy savings of the networks, but also optimize performance of them and take advantage of some of these intelligent automation aspects. So if we were to probably take a closer look at virtualized Open RAN and the automation benefits that it can bring, operators have the ability to take advantage of our AI-based automation solution, and this manages network components and functions. So this is an ORAN compliant platform, again fully open, that enables multiple party end-to-end network automation. So you get to automate, you get to drive your network from a deployment, operation, and optimization perspective. And this brings several efficiency benefits. And again, it works with all these different partners, works across multiple stacks. This is really key, and this is where software-centric kind of programmable networks really start to see some great benefits. I guess a great example of this, as we've spoken about, is what's being done in Vodafone here by everyone on the panel, by all the people involved. Vodafone have made a commitment to Open RAN, a very strong commitment, which Andy's just mentioned, and see the benefits. And it's great to hear that some of these are actually being experienced already by Andy and the team. So I think it's in a very good place, Ruth, and it's good to see the kind of feedback that we're getting both from customers and partners in this respect.
Yeah, brilliant. Thanks, Billy. Thanks for sort of highlighting those features as well that, are super important, things like automation, obviously. We're going to move on to talk about the next topic, really about power efficient operation. And to get into this, really, we want to sort of talk about how we can really use these new power efficient hardware designs and, being able to dynamically place workloads and manage them. So I wonder if Prakash, you'd like to kick the conversation off here and probably add on to some of Andy's previous statements that he's made in the first discussion point.
Yeah, sure thing. Thanks, Ruth. Thanks for the question. So for the sake of this discussion, let's divide the RAN into 3 layers, right? The first one is the infrastructure. That is where you have the quad servers with Intel CPUs, the commercial accelerators, and the NIC card. The second would be the cloud platform. This is where WindRiver comes in with our WindRiver Studio for operators. And the third one is the workload or the applications, wherein Samsung comes in with their VDU and the VCUs. So what I would like to share is how we are innovating in all these 3 layers for energy efficiency. Okay? So at the infrastructure layer, we are working with Intel, who is also a strategic partner, to accelerate the delivery of newer generation processors with inbuilt accelerators and tools that help us optimize power consumption. In fact, we are working with Intel right now to integrate the upcoming Granite Rapids CPU platform for telco workloads. These next-gen processors are high performance, they are energy efficient, and they deliver more bits per watt of energy consumed. Okay? So that is what is happening at the infrastructure layer. At the cloud platform layer, we are reducing the number of cores required to run our platform software. Right? That is what Andy was alluding to. We have optimized our complete WindRiver cloud platform software to run on a single core on an Intel 4th Gen Sapphire Rapids platform. This is the smallest footprint for a cloud platform software in the industry today, thus consuming the least power and enabling additional capacity on the server for additional workloads. So the additional workloads, for example, could be a virtual cell site router. In fact, we demonstrated at Mobile World Congress this year, wherein we hosted a virtual cell site router onto our cloud platform. What that does now is it reduces the number of boxes, the hardware boxes that you deploy at the cell site, thus reducing the overall power consumption at the cell site level. Right? So that is what is happening at the cloud platform level. Coming to the top, at the workload of the application level, WindRiver and Samsung have jointly developed an API that can dynamically adjust Intel CPU C state based on the traffic usage as observed by the VDU. Okay? So by changing the idle states of CPU, the code assigned to RAN application based on traffic demand, meaningful energy savings is possible. Right? This is what Andy was alluding to. Not only do we do something at a macro level, but going down all the way to the CPU level, we're optimizing whatever we can, in terms of energy savings. Now, if you multiply the savings per server times hundreds of thousands of servers deployed nationwide, that would give us some significant savings in energy, right? So this is how we're addressing energy efficiency at all the 3 layers of a RAN stack: the infrastructure, the cloud platform, and the workload.
Thank you. And I think you've nicely it kind of illustrated, the RAN stack and the fact that it is a collaborative, work to be done to be more energy efficient. You obviously talking about with Samsung, but Sindhu, I wonder if you can also sort of talk as well from the Intel perspective about how you've also been working together and what you've been doing to optimize the RAN workloads and be more efficient, really.
Yeah, thank you. I think Prasad laid out a very good background on this thing. And then what I want to kind of come back to is the foundation of the networks. The foundation is really silicon. And the first thing you need to do is use the most power optimal silicon, right? Use the right thing for the right job sort of thing. Now, RAN workloads are very interesting in that they have a very big range of compute requirements. They need a lot of general purpose CPU type of sequential computing kind of resource. And then they need vector matrix instructions for parallel processing for the layer 1 especially, and some functions in the layer 2 as well. Integrated FEC acceleration. And then going forward, we're going to be adding AI in the network as well. So AI has to run efficiently also. So the Xeon processors really support all these functions in a very holistic way So with a single device, you're able to do everything, and that very efficiently, and that is without sacrificing performance and reducing power. So that's one important, like, foundational technology. Then you also look at the whole silicon industry dynamics, right? So general purpose processors have a better refresh cadence. It's a much faster refresh cadence. And the reason, like, each silicon process node delivers more and more performance per watt. If you have a higher refresh cadence, you can definitely take advantage of that for your next processor and so on. So you're continuously improving that for your next deployments. Prakash talked about the 4th gen processors on which they have done significant, Wind River has done significant optimizations and running the whole CAS on a single core. Adding to that, this performance was doubled relative to the 3rd generation processors. So, and then we are already, and this we launched last year, and already we are sampling our next generation processors, which we call codename as Granite Rapids D, and it'll give you better performance per watt. And you really cannot afford this with ASICs. Purpose-built ASIC for one function, you can't afford this level of cadence. So that's another thing that is like a kind of a broader picture if you look at the silicon space. And then advanced silicon telemetry and power management. So you have power-related features, power management features built into the silicon, what we call P states to turn down the frequencies, what we call C states to go coarse to micro sleep kind of a thing, so that you can utilize all these and be able to get very good dynamic power efficiency as well. So at Mobile World Congress this year, there were multiple demonstrations. To name a few, in the Intel booth, we showed 16% energy savings in a VDU using frequency control and some AI assist. In another operator booth, they showed 25% power savings using our C states, which is the microsleep technology, showing 25% power savings, dynamic power savings. And so these are some of the really important things we need to think about when we think about how we design architectures, because this is what it allows. And I think Andy mentioned that, Billy mentioned that, Prakash mentioned that as well. So this is the kind of thing that we need to look at.
Yes, that, I mean, greatly illustrated about the C states and the P states, and almost how you need that granular control and hooks in to give you the full advantage of power saving. Thank you. That's fantastic. Does anyone else want to add on to either what Sindhu said or Prakash before we move on to the next point? No? Okay, so we're going to have, probably the next one's going to be quite a big sort of topic to talk about, because we're sort of talking about intelligence and energy efficiency. And this has obviously been a huge item for Open RAN, especially around autonomous RAN and intelligent control and also orchestration. I wonder, Andy, if we can come to you first, because obviously, getting stuff out in the field now, and you understand and sort of hear from you sort of real world examples.
Yeah, thanks, Ruth. Yeah, I think all of the conversation that we've had before demonstrated how, as we've worked together with our partners, we've managed to bring some significant improvements and understanding in terms of optimizing the platform. So the next step, and a very important step, is how can we operate those platforms in a more intelligent and automated manner? Now, as we've already touched on, the O-RAN architecture provides us with the platforms to do that. But what we now have to see is, how do we transition this into real world environments where we can use this automation and the intelligence to deliver real benefits? Something of a learning curve. The good news is that we have the platform. We have the experience from the work that we've done to bring O-RAN to the state that it's at today. So we have commercial deployments in the UK with other markets in the not too distant future. But now we need to be able to leverage some of that R&D work that Sindhu was referring to, that was demonstrated at Mobile World Congress, and start to bring that into our commercial platforms, both in terms of how do we optimize that platform to meet some of the KPIs that we have, and that can be clearly performance related, but then also balancing that performance against some energy targets as well. So delivering just enough performance, but we don't want to necessarily deliver more than we need to, because that's going to cost perhaps more compute processing or more power in the PA. So what we need is the ability to understand much more about what the network is doing, and on a cell level, perhaps what that cell needs to do in the next 5 or 10 minutes by predicting traffic that's happening in cells around it. So this is about really taking some of the base principles from what was originally self-organizing networks, but adding fresh intelligence that we can pull from more service sources. And this is why when I referred earlier on to looking at it as a holistic network, we want that end-to-end connectivity, the ability to understand exactly what's happening in your compute processor and ensuring that that is mapping what's happening in the radio. And if those two things are not working in synergy, then we've got energy that's being consumed that doesn't need to be. So we're really starting now to look at how do we get those hooks in place. So that's working with silicon vendors, working with the O-RAN Alliance to develop the interfaces and the information that can run across, and then understanding what do we need to feed into the machine to enable it to make some of those decisions. So at the moment, what we see is that we can make some significant configuration changes to the network, generally at the off-peak hours, and especially through the night, where we can switch carriers on and off, for example. Now that saves considerable energy in the power amplifiers and in the radios. One of the challenges we have is how quickly can we spin the network back up if we see traffic approaching that we need then to be able to support. And this is an area that, how do we get some of these both closed and open loop controls working more instantaneously? And if we can have greater granularity in how we manage the hardware aspects of the platform, we can bring significant power efficiency through that capability. So we're starting to see lots of vendors. We're starting to see some really good innovation that was demonstrated at Mobile World Congress, and I'd anticipate that we will see much more of it next year. And the good news is, with open platforms, we can drop these onto the RIC or into the SMO, and then we really start to see how intelligence can be implemented along with automation, and we can measure it against our KPIs. We know an awful lot about how the network works today, and if we can save just even a few single-digit percentages across several areas of that platform, it all adds up and will help us deliver against our targets. And we are looking at year-on-year improvements, and all of the vendors here that I've worked with and we work with for a good number of years know that there's never any endpoint to this. It's always like, well, that was a fantastic improvement. We've got Open RAN now to a point at which it's highly competitive. It delivers the services that we need. It meets the KPIs that we're looking for. But okay, what comes in next year's software release? And that's absolutely about introducing the intelligence, the automation, and continuing to push power efficiency as a number one criteria for us.
Yeah, thank you, Andy, also for highlighting the synergy, because obviously that is the heart and soul of O-RAN, and working and understanding what's happening across all these different layers and infrastructure, radio, etc. Billy, maybe we could come to you next, just to sort of hear your thoughts about sort of the RIC and how you see it sort of assisting or developing.
Yeah, sure. I guess, as you've heard, and it's been a very common theme throughout, is automation is a really key aspect, and it's fantastic. And there's a lot of automation that's going to bring benefits for operators. Automation coupled with intelligence is another step forward, and this is a really key thing. So one of the things, if we look at RIC from an energy consumption perspective or an energy efficiency perspective, is how it marries the two. So the RIC provides operators with on-demand deployment of network capabilities or more intelligent management, and that can be quicker optimization of usage patterns. And from here, you can increase the value of your 5G investments. Andy mentioned there that at the minute, it's nighttime, largely kind of management of cells. This is where we can go to and bring more automation, more intelligence. But also, as we look at 5G and SA networks and the associated benefits like network slicing, which become widely available, operators who deploy an Open RAN architecture are going to have the ability to deliver service assurance via the slice. That's going to be optimized with greater visibility, with greater flexibility, and with access to intelligence and the apps on this RIC. So applications here can be things like network traffic prediction, which is a very good fit for exactly the topic that Andy just raised, or QoS-based handover parameter optimization would be another one, maybe from a performance perspective. So that's kind of a key component of the RIC and a key aspect there. We see 5G networks also moving towards virtualized cloud-based architecture. Networks are evolving and becoming more complex by nature, just through the evolution of standards, through everything. So there's always challenges of managing these increasingly complex networks. To do this, we need intelligence and we need easy solutions that can help operators manage the complexity. On top of this, I would say we are also looking at fostering innovation in terms of time to market, performance boosting. So all these are kind of aspects where we see the RIC doing it. In addition, I think the RAN will need to accommodate diverse use cases, devices as well, while providing best possible user experience to each one individually. So again, lots of complexity coming through the evolution of these networks, and new intelligent applications are emerging as the solution. And this is where this RIC is emerging. I mean, if we were to take a step back maybe and try and simplify this, RAN applications on a RIC platform are really quite similar to kind of smartphone applications. If we were to go back 20 years or 25 years when 2G phones only supported voice calls and subscribers needed a different device for every kind of different functionality that they wanted, smartphones changed that. Now you can download various apps all through software. Similarly, with the RAN applications, operators are in a position where they can easily deploy the necessary functions to improve things like energy efficiency, to bring flexibility of their Open RAN, but they won't need different hardware for each function. This is again is a software-driven aspect, and this flexibility and adaptability of the RIC, I think, will be vital to keep pace with 5G innovation. So I think it's a very important role to play, and I think it's a really interesting segment, I would say, Ruth, from our perspective.
Yeah, thank you, Billy, and thanks for also highlighting obviously the flexibility. We've got really diverse use cases, so we're going to have to add all these tools together to really, like you said, simplify and try and get this manageable. Prakash, I wonder if you can maybe extend, both Andy and Billy both mentioned sort of AI, ML, but I wonder if you can sort of extend your thoughts around this and what you think is going to be important.
Yeah, sure thing. Thank you, Ruth. I think this is the first I heard an analogy of RIC, and thank you, Billy, for that. Like comparing RIC to apps on a smartphone. That's the first I've heard. Thank you. Makes sense. So coming back to AI ML, something to note: machine learning is not new. Right? We used ML in our traditional network. Andy mentioned that self-optimizing network, right? We used it for mobility optimization, wherein you had seamless handovers coming in. But what is new, though, is cloudification, which has given rise to new architecture. What is new is opening up of proprietary interfaces, like Andy mentioned, for Open RAN, which has given us an opportunity to introduce new software-defined functions, such as SMO, RIC, enabling closed-loop automation that can self-optimize, self-heal the network, right? So that is new. Now, coming back to the question, if I were to focus specifically on AI ML driven use cases to achieve energy savings, then a few come to mind. Going back to what Andy was saying, dynamic power management, which is also called as adaptive power control. We have a lot of AI algorithms that dynamically adjust the transmit power levels of base station based on real-time traffic demands, thereby reducing energy consumptions during periods of low usage, of course, without compromising service quality. And these algorithms are typically derived based on the time of the day, the traffic patterns, network load at any given instant, etc. In fact, I recently read that British Telecom in UK has implemented an energy saving feature called as cell sleep technology, if I get that right, across all of its sites nationwide. And in that case, the cell sleep software works by putting certain 4G carriers to sleep when the capacity is not needed. And the excess capacity estimation is based on machine learning predictions of load traffic over a period of time. That's where ML comes into picture, right? Another use case, Billy mentioned, network traffic prediction and optimization. We can use ML models to predict traffic patterns and volumes, enabling proactive adjustments in network configurations to basically optimize energy use. We can use AI-driven load balancing to distribute traffic more efficiently, more evenly across the network, thus optimizing the overall power consumption. Right? Someone also mentioned that now there are a lot of deployments of 5G standalone, and what that does is that enables one of the biggest features of 5G, network slicing. And with service-based architecture, especially with control and user plane separation, it has given us the ability to dynamically allocate resources, such as bandwidth, processing power, in real time per slice. That can improve energy efficiency. So I think in general, there is a lot of potential for AI ML-based automation. And today, with the virtualization happening, with the digitalization of the network happening, there is a lot of telemetry that can be that we can obtain from infrastructure, platform, and workloads that can be used for new ML models for like the fault RCA prediction, scheduling maintenance windows more effectively. We can build self-healing capabilities with closed loop automation. So there are a lot of these different AI ML based use cases. And if you go to higher layers in the stack, especially with Open RAN, like Andy mentioned with SMO, there are RApps and XApps that add additional capabilities in the network in terms of optimization and performance enhancement, all based on some form of AI algorithms.
Thank you. That's a really good summary of all those topics. Like you say, it's touching everything, isn't it? Really, Sindhu, I wonder if you can kind of link into that, because obviously, with Intel, to enable proper AI ML efficiency, it's going to start with the basics of silicon. And how are you seeing that? How are you seeing the hooks into the other layers? Perhaps you could share your thoughts.
Yeah. So I think as Prakash mentioned and the others as well, right? Like we do have enough proof points now that AI is going to benefit RAN optimization, whether it's sustainability, it's using the same resource for additional capabilities, what have you. But the question comes up, can we add AI in a power efficient way, right? So that is what we need to answer. So we have worked for over 3 years now with different industry partners internally and so on, looking at this exact question in terms of what kind of ML models are really useful here. And our conclusion is interesting. It's like virtually all of these ML models for optimization, RAN optimization, they are small relatively, few layers. They operate with a small handful of parameters like RAN KPI coming in, are you kind of oversubscribed, these sorts of 3GPP parameters, but they also have very stringent latency requirements. So you need to be able to handle all those 3 things at the same time. And the Xeon processors, we support a lot of AI acceleration. matrix and vector processing instructions, vector neural network instructions, and so on. And we also have a software framework and tools to be able to use these very efficiently. Many of them are open sourced as well. So these ML models we have found run very efficiently on Xeon cores. We showed 3 of these AI-based demos at MWC this year, one for power management, one for network slicing, which the others brought up as well. And then one for beam management. And how do you improve cell coverage for people who are, kind of at the edge of the cell while not having to add more resources, right? How do you optimize with beam management? So the other thing is, if you're executing on the same processor that you're executing other things, you're not having to go off chip to, for the ML compute, which means you're also not incurring the latency. So that is also super important. If it doesn't come in time, the result doesn't matter, really. So you can get the sustainability and other benefits of AI without having to add power-hungry devices like GPUs that would significantly increase power.
Brilliant, thank you. So I'm keen to move on to the next one, because I know we want to sort of talk about reaching carbon neutrality, which is everybody's kind of end goal, isn't it? And we also, because this is a whole ecosystem conversation, and also Cindy, you've spoken about it, and so has Andy, and also Billy, we want to give everyone a chance to do that. But I wonder if we could come to Billy first, just about your thoughts on, how do we get to carbon neutrality? What are our guiding principles, in this huge ecosystem to work efficiently, and what do we need to do?
Yeah, sure. I guess from carbon neutrality, and this, if we think of it, it's quite similar to some of the other topics we've discussed, in that data is really everything. And data helps us to make the most informed decisions. And that sounds like a very simple thing to say, but it's quite complex behind it, because data in itself is abundant and maybe not so useful without relevance and contextual kind of insights. And these are needed really to make it easy for an operator to make decisions about their network and to strive for this carbon neutrality. So I think when we talk about where we look to go, we combine the data that's there and the tool sets with some of these intelligence and the availability of AI and analytics. And when we bring these together, we see a game changer really in terms of this. And operators are getting the opportunity to easily increase their efficiencies. This can be in kind of a number of different fronts. You can minimize human error through these tool sets. You can flexibly activate network changes, upgrades, downgrades, cells on, off, all these various aspects. But in its most essential form, you can better manage the performance, you can better optimize the energy efficiency and the usage of your network, and you can strive towards this carbon neutrality. And I think that's really the big game changer that we see, is the ability to manage all this data and to give it context and the relevance to make these informed decisions, and that's going to play a huge part. So,
thank you, Billy. Cindy, I wonder if we can come on to you, and I'm also keen. We've had a question as well about people talking about the frameworks, the metrics, the KPIs, and using all this data that Billy also sort of spoke about, and how you think we're going to achieve or work towards this.
Yeah. So I think, first of all of us in the industry need to take responsibility for this. This is not the operator's problem. It's not the silicon vendor's problem. We all got to get together for this. And there is no silver bullet either, right? It's not like you do one thing and you're done. So it does take multiple approaches that we need to simultaneously work with in order to be able to achieve these goals that we have. So we really believe that we all have to work. It's not just about partnerships, collaborations. It's about one team. Really, we need to tackle this as an industry, as one team. So that's one thing. Then finally, I also would like to bring up the issue of scope 3 emissions for operators, because we are really scope 3, right? So the silicon vendors, it is very foundational in networks. It is consuming power. So Intel has been at the forefront of addressing this. Over 3 decades ago, Intel started on this journey. We are a top 3 semiconductor company, and what we do will make a difference in the power arena. A few examples. As of 2023, we are at 99% renewable electricity across all our operations worldwide. We also had a 43% reduction in Scope 1 and Scope 2 greenhouse gas emissions from the 2019 baseline. Since 2021, actions that our suppliers have taken, we track them as well, right, to reduce greenhouse gas emissions have resulted in an additional 9% of savings. So all this, like, it's up to all of us to really take that ownership, kind of set goals, and then track them, and then invest in this in order to be able to have a sustainable planet. Ultimately, I think, future generations are not going to only look at the cool technologies that we enabled and made fast mobile networks and so on. They're also going to look at how sustainably we did that. Did we leave them with a livable planet? Mm-hmm. So that's my take on this.
Thank you. I love the point you also made about we're all one team, which, is both how we have to think about the evolving ecosystem and also energy. It's a joint effort, isn't it? Andy, from an operator perspective, maybe you could comment a little bit on your thoughts.
So, I think for this, it's for us very much about looking both at not just the platforms, but also the operational aspects. We've seen how in the past, design for performance has driven a lot of what we've done in our networks, the type of products we've been demanding. I think we're actually moving to a phase now where design for efficiency is going to be as important, if not more important. And the key thing there is that really what's evident already from what we've been learning is that if you design from efficiency, you have to do that from day one. And with those, with those components, and then working very closely with your partners and with the industry, enables us to move that forward very, very efficiently. So I think it's super keen that we get to really look now. We've reached a level which we're comfortable with in terms of our performance with our efficiency. We've made good progress, but super critical now is the next sort of 2 to 3 years where I think we can make some more significant steps, leveraging the intelligence.
Okay, thank you. So we're going to move on to our kind of last kind of point, which really, I guess I want to ask each of you, what's next? How do you think the industry work better? So I know we're sort of starting to get up to the top of the hour, so maybe if I can ask you to have 1 minute each and your thoughts around this. So maybe if we come to Sindhu first.
I think we need to speed up the network transformation to open virtualized RAN. Deploy the power savings technologies that we already have. We have already proven them out in networks. Apply cloud native technologies for automation. Prakash also mentioned that. And then continue to innovate, continue to collaborate and innovate so that we can bring the promise of AI as well to the sustainability challenge.
Thank you. Prakash, what are your thoughts?
Yeah, thanks, Ruth. I think achieving energy savings is, like in the telco industry specifically, requires collaborative effort, as everybody pointed out. I mean, the stakeholders are numerous. It's the one team, like Sindhu mentioned, the telco operators, equipment manufacturers, regulatory bodies, technology providers. And I believe it all starts with standardization and collaboration. So defining the standards in 3GPP and O-RAN Alliance is the first step towards achieving a common goal. The next step is to collaborate and participate in joint research, especially the ecosystem of partners right here. I mean, developing new initiatives to share best practices and innovation. From a regulatory perspective, I believe the government should promote and incentivize energy efficiency and use of renewable energy sources in telecom networks. From a technology adoption perspective, and this is where we come into play, like Sindhu mentioned, we should accelerate the adoption of virtualization basically to improve resource utilization and reduce the need for energy-intensive hardware. So there cannot be a single approach to solving the rising telco energy cost. I believe energy savings is a continuous improvement process, and we should address it from as many aspects as possible. Even small incremental benefits at the CPU level, at the server level, will eventually add up to substantial savings when you look at the complete network.
Thank you. Billy, just a sort of your 1 minute snapshot on what you think the industry can do better, or perhaps a call for action. What are your thoughts? Sure,
yeah. I think it's been touched on quite a lot, but its key thing is we have to continue to work together as an ecosystem. And I think we see that in probably 3 areas that we see there's drive forward. The first is continue the software-driven programmable networks kind of focus and utilize AI and automation. And I think we've seen that in a micro level throughout this discussion, but also on some macros. But as a principle, it's a guiding principle that will bring optimization, efficiency, and flexibility. I would say the second one is continue to see advances in the miniaturization of chipsets, because this will increase energy efficiency and the power of vRAN products. It also, when we look at radios, reduce the size and weight also. So it's a key aspect, not to be forgotten. And I think, as was just mentioned, we will see an evolution of standards. We'll see new technologies like RedCap rolling out, enabling more 5G use cases. So I think keep focusing on software-driven programmable networks, keep miniaturizing chipsets, making them more powerful and energy efficient, and keep pushing standardization and promoting the newer technologies. And I think these 3 will all drive us in the right direction, especially if we come together as an ecosystem and work on them.
Yeah, thank you, Billy. Andy, your thoughts as well, please.
Super quick then, in a minute. I think, focus design on efficiency, make that a priority. Work hard to enhance software, bring automation and intelligence. Continue to drive hardware development and bring fresh options into the marketplace. So more innovation, more alternatives. And then from an operator's point of view, stabilize that hardware platform. We can't have too many changes happening too regularly. We need to minimize truck roll to site. We need more resilience in the platforms. And we can do some of that by driving more automation. And increasingly, we're heading towards a software-defined radio network and a very stable hardware platform. And then lastly, but super important, is as everybody said, continue to build on industry collaboration, and especially leverage the forum, the specifications, and the work that's being done in O-RAN. Any vendors here today that are listening to this, I hope you get the message. If you're not in O-RAN, you really need to be participating. That's how we're going to secure the very best future, and collaboration really is absolutely key, and I think that's really what O-RAN is about, and that is how we will succeed.
Thank you. And I know we're sort of reaching the top of the hour now, and I think you've kind of perfectly formed the end of the discussion, just saying collaboration really is key, making sure everyone's speaking to everyone, and keeping the conversations open. So we've come to the top of the hour now. I know we've got a number of questions, some of which we covered during our panel discussion. We will have these questions. We'll be able to get back to you where relevant. We'll be able to answer. So the panelists do have those. So please don't worry if you've added a question into the Q&A window. I'd like to thank you all for joining us today. There's been some fantastic questions, some really great discussion and insights from Andy, Billy, Prakash, and Sindhu. Thank you for sharing such important kind of real life examples and your thoughts on this. I'm really appreciated. So thank you for that. I'd also like to thank Wind River as well for sponsoring today's session, and also opening up this conversation, especially to make it a collaborative discussion across sort of Intel, Wind River, Samsung, and also Vodafone. So thanks everybody for joining today. Hopefully we'll see you again soon on another webinar. But for now, goodbye.
Thank you.
Thank you.
Thank you, everybody.